Welcome to a special evening edition of the Center for Data and Computing Distinguished Speaker Series for winter quarter 2021. We're really excited to have our guest tonight, Kate Crawford, who will be speaking to us from the other side of the world. But to start us off, we'll do an introduction from CDAC Director Nick Feemster. Take it away, Nick.
Thanks, Rob. Welcome, everybody. Thanks for everyone for joining us tonight for this, what is a conclusion of a really exciting speaker series. For those of you who aren't familiar, the Center for Data and Computing is a relatively new center at the University of Chicago. It's designed as an intellectual hub for data science research and AI and machine learning research across campus. What does that mean? What is data science at U Chicago? Well, as a university that likes to blaze new intellectual trails, we think we're doing that here too. And in particular, data science at U Chicago encompasses the applications of statistics and machine learning and AI to just about every other discipline that exists on campus. I think the center sponsors research in just about every academic unit on campus, from the Oriental Institute to the School of Medicine. And I think in that spirit, I think it's a great segue for me to introduce today's speaker, actually, who really embodies just a beautiful interdisciplinary view of machine learning and artificial intelligence. Kate Crawford, I'll read some of her bio in just a minute, but I think I'd like to say that when I saw Dr. Crawford's keynote at NeurIPS, maybe must have been 3 or 4 years ago by now. She started, maybe it was even longer, I don't know. Time flies. She really started talking a lot about how machine learning and AI can have bias in it. And actually I have to say that was kind of puzzling to me at the time as a computer scientist, and it took me a while to wrap my head around it myself. But I think what Kate has really articulated beautifully, both in some of her initial thinking on the work and really seminal work, but also in her forthcoming book, The Atlas of AI, is that artificial intelligence is not a purely technical phenomenon. It is really something that interfaces it's really part and parcel of the real world, right? And it's not magic, right? It is what we make it. It is how we design it. And I think the Atlas itself has, I think, at least 6 chapters in it talking about different aspects of that. One of them, and I'll tease the book for you, Kate, there's one that has a beautiful history of the Chicago stockyards and a reference to Upton Sinclair's The Jungle. So for those of us in Chicago, I think we'll all truly appreciate that. But I think we're here to hear from Kate tonight about both some of what she's written about in her book, as well as sort of this interface between AI, society, and the world. And so, Kate, I think with that, I'll turn it over to you. But thank you very much for I think opening our eyes to these important issues, and we're looking forward to hearing your thoughts tonight. Thank you so much. I should say this morning. Welcome from Sydney.
Thank you so much, Nick. That's such a generous introduction. It's a complete pleasure to be here. And I just wish we were all doing this in person, but another year, perhaps. I'm just going to start my presentation. So we will kick things off in just a minute. Let's try this. Okay, hopefully you can see that and we can get started. All right. So Nick has really, I think, done an extraordinary job in creating this series at U Chicago, and I've really been enjoying watching it from afar. And it's been centered on these questions of bias and bias correction, and specifically how machine learning applications can avoid the creation of negative effects and deepening social inequalities. So in response to that, and sort of wrapping up this series, I really want to talk about how our theories shape our tools and vice versa. and why I think some of the technical approaches to bias sometimes mask deeper issues of classification and power. So let's start here. This is a story from CNN a couple of weeks ago. It's about a new AI system that is being used by schools during the COVID-19 pandemic. Now, this system claims to assess children's emotions while they're working on computers and classifies them as feeling one of 7 emotions: happiness, sadness, anger, surprise, fear, and neutral. The system also monitors how long students take to answer questions, and it forecasts their grades. Now, as you can see from this headline, it's stated as a fact that this AI can read children's emotions. And if you can see the caption just down the bottom there, it says, and I quote, "If the corners of their mouth are raised, the machine detects happiness." Now, I would suggest that any of us who have smiled because a photographer told us to, or who've held down jobs in the service industry, probably know that this isn't necessarily the case. But there are deeper questions to ask here too. For example, where did we get this framework of 6 emotions plus neutral? And why do we assume that there is a fixed relationship between a person's facial expression and their true emotional state? Or that the relationship between facial muscles and inner states is consistent, measurable, and uniform across people, regardless of their age or their culture or their context. So I'm going to suggest that we need to be much more skeptical, not just about these sorts of claims, but about how machine learning systems currently interpret humans, in particular, people's inner states, identities, or characteristics. Further, where does ground truth come from in machine learning? And what kinds of politics inform how our machines are taught to see the world? Now, to address this today requires that we go into some of the most contentious debates in machine learning. I want to look at the historical forces that have shaped the systems that we have today, where a set of beliefs were then made into software under the guise of objective science, when in fact those beliefs are often fraught and contested. So what is at stake here in these sorts of questions? And frankly, why should we care how AI systems classify human behaviors and inner states from faces? Well, let's look at examples of how something like emotion detection, as it's often called, or affect detection, is already used. Right now, it's in job interviews to assess the micro expressions of job candidates' faces, and then they are compared to their top performing employees. It's also used by the insurance industry to detect fraud. It's used in the automotive industry inside cars to detect if a driver is possibly feeling negative emotions. And in fact, one recent product noted that it would alert nearby police if drivers looked sufficiently agitated or distracted. So you can imagine that there would be some real issues that could emerge there. And it's also being used in shopping malls to predict who might be a shoplifter by looking at the circled emotions on their face. So we're starting to see emotion detection already playing a role in some high stakes domains with no oversight, with no clear regulation, and in some cases, even without strong evidence that they work. So I would like to suggest that there's much at stake in how AI systems classify us, from emotion to gender to race to criminality and personality, because all of these things are already being done, but they can be doing this in a way that amplify existing structural biases in ways that are both invisible and unaccountable. Now, scientists have been concerned about this problem for a long time. One of the earliest pioneers of AI warned decades ago that we ran the risk of being so seduced by artificial intelligence that we would ignore its deep social implications. This is Joseph Weizenbaum, the man who invented ELIZA. Of course, ELIZA was one of the first chatbots, and it emulated a Rogerian psychotherapist, simply by using scripts and pattern matching to respond to people and essentially to simulate conversations. But people frequently believed that ELIZA understood them. In fact, Weizenbaum's own secretary would ask him to actually leave the room so that she and ELIZA could have conversations. Now, after watching people's reactions to ELIZA, Weizenbaum was convinced that a broader phenomenon was at work that he called the powerful delusional thinking of AI, that some people would assume that these systems are more intelligent than they are and believe them over and above non-automated sources. Now, this phenomenon would later be called automation bias, and it's been studied in many different kinds of contexts, from autopilot systems in planes to hospital systems to nuclear power plants. And we've had, almost 60 years, I think, since the creation of ELIZA. But in many ways, I think that phenomenon that Weizenbaum noted has only developed and grown. I think we continue to see this belief that computational systems are almost superhuman in their sort of predictive capacities. In a recent paper with Alex Campolo, who's currently at the University of Chicago, we looked at a phenomenon that we call enchanted determinism. Specifically, how deep learning techniques are discussed often in papers and public fora as almost magical and outside of the scope of our present scientific knowledge, yet also deterministic, in that they can detect patterns that will give unprecedented access to people's identities, emotions, and social character. Now, the problem with this sort of enchanted determinism is that it tends to distance machine learning designers and the corporations that employ them from responsibility and legal liability, because these systems are painted as too complex or beyond human understanding and regulation. Now, I would suggest that these claims are not just problematic from a scientific perspective, but from an ethical and political perspective as well. So today I'm going to address 4 themes. Briefly, how is AI made? And I'm thinking about that in the broadest possible sense. Then I'm going to talk about bias and how some of the attempts to technically fix bias often fail to address the deeper dynamics of classification. Then I'm going to consider what I call the face fallacy as an example of these deeper classificatory harms that are sort of contained within the phrenological impulse. And then finally, I'm going to end on how some of these systems are amplifying asymmetries of power. So first of all, how do we make artificial intelligence systems? Well, in my research, I tend to look at AI as 3 things: technical approaches, social practices, and industrial infrastructure. Now, as everybody here knows, the technical approaches of AI have changed dramatically over the decades, from symbolic logic and expert systems to what we now call machine learning. Now, of course, for supervised and unsupervised machine learning, these systems rely on enormous amounts of training data, which I'm going to focus on today. The second component of how we make AI systems is social practices, by which I mean who works on these systems, who decides which problems will be prioritized, where data will be harvested from, and how humans will be classified. That powerfully shapes the types of systems that we have today, just as much as algorithms do. It also really matters who's in the room, and sadly, the AI field is still very demographically skewed. As I and other researchers like Sarah Myers-West have noted over the years, AI has a white guy problem, and currently over 78% of workers in the AI field are men, and over 80% of all AI professors are men. This is creating a very powerful monoculture, one that is also shaping the kinds of problems that our systems are designed to address, and which populations are best served by those tools. Finally, AI is also a massive industrial infrastructure. This image here is a map of a single Amazon echo, which was created by myself and Professor Vladan Jola. Now, we made this to visualize all of the things that have to be drawn on and extracted in order to have a system like Alexa. So we can ask Alexa questions like, "What's the weather today?" or "Please play my favorite song." That moment of convenience calls into being a truly planetary computation network. And I think those costs of extraction are really admitted or even tallied in full. And frankly, only a few companies can do AI at scale like this. Fewer than a dozen, really, depending how you count. So AI is a profoundly concentrated industrial infrastructure with far-reaching global consequences. So at each one of these layers, the technical, the social, and the infrastructural, AI is rearranging power, economic power, social power, and scientific power. And it is configuring who can do what, with what, and who will benefit the most. That means we need to study its social, political, and even ecological ramifications, I think, with far greater seriousness. Now, in my new book, which Nick mentioned, Atlas of AI, I argue that AI is neither artificial nor intelligent. In fact, AI is profoundly material, made from vast amounts of natural resources and energy, human labor, and data. And AI systems are not intelligent in the human intelligence sense, nor are they objective or neutral systems. As we know, they can't really determine anything without extensive computationally intensive training with large data sets and predefined rules and rewards. So while we have a tendency to think about AI as disembodied math, these systems are anything but abstract. So one of the early moments of the AI field being forced to contend with how we represent and impact human societies has been the bias debate. So let's turn to that now. About 10 years ago, I started researching issues with bias and skews in what we were seeing in large-scale data systems. If you remember, we used to call them big data. Back then, it was a much smaller field. And as Nick said, this idea of bias was still seen as a sort of a niche issue, if really an issue at all. But now the examples of bias and discrimination in algorithmic systems are everywhere, from Apple's credit worthiness algorithm to racism in Compass's criminal risk assessment software, to age bias in Facebook's ad targeting, to image recognition tools miscategorizing Black faces, to chatbots adopting racist speech, to voice recognition software failing to recognize female-sounding voices, and to social media platforms showing higher paid job advertisements to men rather than to women. Now, as scholars like Ruha Benjamin and Sophia Noble have shown, there are hundreds of these examples throughout the tech ecosystem. But frankly, there are many more that have never been detected or publicly admitted. So why does this keep happening? Well, again, I would suggest that there are reasons at each layer: the social, the technical, and the infrastructural. Now I'm going to turn to some of the technical infrastructure issues that I see occurring when it comes to training data. Now, of course, you most likely know this image. It's from the canonical training set that is known as MNIST. Now, MNIST, of course, was drawn from handwritten digits that were assembled by the National Institute of Standards and the Census Bureau. So when people were filling out their forms, all of those handwritten digits became part of this training set. In fact, Jeff Hinton refers to MNIST as the Drosophila of machine learning, named after, of course, the fruit fly that is used so much in genetics and beyond that it basically became the sort of standardized platform for so much scientific research. And like the fruit fly, benchmark training sets have become standardized platforms in machine learning research. In fact, they're just used so widely by academic labs and corporations alike that they've just faded into the background. In short, training data has become the ground truth from which many machine learning systems are built. But where do these ground truth data sets come from? Who creates them? What goes into them? And who decides what's included and what is left out? How do we account for their provenance and their limitations and their implications? Given their profound influence on machine learning, I think it's critical that we understand in much more detail how they work. Now, one of the first projects I did in this space, I did with colleagues at FATE in Microsoft Research. I should say FATE stands for Fairness, Accountability, Transparency, and Ethics. It's a group that I co-founded back in 2016 with my colleagues Hannah Wallach and Fernando Diaz. The Datasheets project was led by Timnit Gebru, who was a postdoc at the time and who I know has also given a great talk in this series. And we did this project to address the lack of any standardized process for documenting what data sets contain. Now, in 2018, we published datasheets for data sets to basically look at ways you can document your contents of a data set, your test results, and potential privacy and ethical issues with that data. And that was then built on by Meg Mitchell and her colleagues at Google to produce model cards for model reporting in 2019. But how do we know the way that categories of data work? In other words, what worldviews are contained within the classificatory logics of training sets? Well, to answer this, I did a 3-year project with the artist and researcher Trevor Paglin called Excavating AI. Now, beyond documenting training sets, we wanted to investigate the underlying logic of how images are used in computer vision. We looked at hundreds of training sets, from the very first experiments in facial recognition in the early 1960s to massive contemporary training sets like ImageNet. Now, methodologically, we call this project an archaeology of data sets. That is, we were digging through material layers, cataloging the principles and values by which they were constructed, and then analyzing the normative patterns of life that were supported and reproduced by these sets. Now, by excavating the construction of training sets and their structure, you can begin to see the many unquestioned assumptions that they're built on. And I think they inform some of the ways that machine learning systems work and fail to this day. Now, of course, ImageNet was one of the training sets we spent the most time on, truly in this case, like over 18 months just studying its construction. And the reason we dedicated so much time to this, of course, is that ImageNet has changed the landscape in terms of how computers detect and recognize objects and images. Now, ImageNet was published 11 years ago by researchers at Stanford, who stated that their aim was to map the entire world of objects. It is very quickly became the gold standard for computer vision research, and it consists of over 14 million images. The underlying structure of ImageNet was adapted from the semantic structure of WordNet, which is a database of word classifications created at Princeton in the 1980s. But for ImageNet, took only the nouns. So how would the team manage to label by hand 14 million images into 20,000 noun categories? Well, the first idea was to hire undergraduate students to do it manually, but they realized that would take huge amounts of money, or potentially 90 years. So they decided to use what was then a very new service called Amazon Mechanical Turk. That meant that they could access distributed labor forces to do online tasks at low cost. So ImageNet was built by an army of piecemeal workers, sorting on average 50 images a minute into thousands of categories. And of course, there are lots of labor politics here too, but we'll have to save that for another talk. Now, the result is this massive and intricate data set. If we look at a noun like apple, that might seem pretty non-controversial. But not all nouns are created equal. Some of the real problems in ImageNet begin to emerge when we start to apply these nouns to humans. Now, ImageNet contains over 2,833 subcategories under the top-level category person when it was first released. The biggest category is gal, followed by grandfather, and then chief executive officer, which is almost entirely images of men. Now, with these highly populated categories, you can already start to see the outlines of a worldview. And in fact, ImageNet was released in order with these classifications of people for race, nationality, profession, economic status, behavior, character, and even morality. And some of the concepts aren't even visual at all. For example, we would look at categories like debtor. What does it mean to have a picture of a person that is supposed to relate to their bank account? How can you see what their relationship is to debt? Then the nouns begin to shift from descriptions to normative judgments, as we see here in the category of bad person. Others are more unpleasant. Here is one for hypocrite or dissembler. And in fact, we found many categories that are genuinely offensive. Some are racist, ableist, or misogynist, while some, frankly, are just not repeatable in a public lecture, so I'm not putting them in this list. Now, remember, these are labels for categories that contain thousands of images of people scraped from the internet, people who generally have no idea that their image is being used this way, or that it's contained in one of the most influential training data sets in AI's history. So to underscore the point here, the problem is not one of technical bias. This is not an issue of needing more racial or gender diversity in these sorts of categories. It's actually the categories themselves that are offensive. And ultimately, it's this process of classifying people like this that raises fundamental problems. And of course, training sets affect thousands of production systems that are operating in the world. This image here is from YOLO 9000, which is a model built on ImageNet's people categories. And you can see what happens if you give it an image like the Situation Room during the Bin Laden raid. Here it's, again, labeled with ImageNet categories. And you can see that The men wearing ties up the back have titles like security consultant or microeconomist. But if you look up the front, Obama is a demagogue, and over here on the right, Hillary Clinton is labeled as a sick person. So there are these troubling logics that emerge in the way that ImageNet orders information, which is then influencing untold numbers of technical systems around the world. So after our study of ImageNet, we gave talks, we published the Excavating AI paper about our findings, including our concerns about racist and offensive frameworks. We also curated a major art exhibition on the history of training images, which kicked off a much broader public conversation about the epistemic foundations of machine learning. Subsequent to this, the ImageNet team released their own paper indicating that they would delete more than half of their categories which they agree are offensive. Over 600,000 images were found to be offensive, and only 6% of the person categories will remain. Now, this is a dramatic shift. And in addition, they're going to work on remediating bias, in their words, by adding people with different skin tones to categories to enhance their diversity. But I would ask, does this address the fundamental issue? Well, I certainly think it's a good thing that sexist, racist, and ableist images and categories are removed. And we've certainly seen more of that happening in the years since we did Excavating AI. We've seen another terrific study by Abiba Birhane and Vinay Prabhu, which showed similarly offensive classifications in MIT's giant data set called Tiny Images. Now, MIT responded by taking down that data set, as did Microsoft after critical research into its training set, MS Celeb, was done by the artist Adam Harvey. And I think it's actually just like an interesting side note here that art and artists have been an important part of reflecting on these training sets and producing some real change here and really introducing this issue to a wider public. But it doesn't mean that these problems are solved. First, these training sets are still out there, dispersed in the research community on torrent sites, and these ways of seeing are still propagating throughout commercial systems. Second, the epistemological questions remain unanswered. What happens when we seek to classify people in AI in the same way as objects? What happens when those labels move from the descriptive, like an apple, to normative judgments, like bad person? And what racialized and gendered logics remain in these systems? And who gets to make these determinations? As you can see, these are some of the really hard questions that have to be asked about training sets in machine learning. And it's particularly important because these training sets are being applied in so many sensitive domains, from healthcare to education to criminal justice. And that means their impacts are often quite opaque. It's difficult to see how they're actually influencing systems. So I think it's important that we distinguish between these narrow bias mediation tech fixes, such as scrubbing away offensive images or deleting categories, from the core questions of classification here, which is how labels are being attached to people. In fact, as someone who's been working in this field for many years, I'll be honest, I'm concerned that some of the current attempts to narrowly address technical bias mean that these deeper questions of classification and epistemology are never being addressed. So let's have a look at how this plays out in emotion detection. As we know, these are already systems that are being applied in airports and schools and job interviews. But considerable recent research has shown that they're based on a highly contested scientific premise. In fact, a comprehensive review of all of the scientific literature on inferring emotions from facial movements was recently published by the psychologist Lisa Feldman Barrett in 2019. And this study was absolutely definitive. It's found, and I quote, "no reliable evidence that you can accurately predict someone's emotional state from their face." So how did this become such a commonplace thing to be happening in machine learning? Well, we need to go back in time to understand that, to this man. This is a psychologist by the name of Paul Ekman, who became a towering figure in emotion analysis. This image is of him in Papua New Guinea in the 1960s, where with financial support from the Department of Defense, he went to do cross-cultural research on the four people. He wanted to show that facial expressions were universal, regardless of culture. And he did that by taking images of posed emotions like the ones you see here, that is, people mimicking emotional expressions, And he would then show these pictures to people in remote tribes, like the Fior people, and to see if they would actually agree with his descriptions of these as universal emotions. Now, Ekman, of course, wasn't the first person to try and capture emotion and fix it into categories. It has a much longer history. He was influenced by people like Duchenne in the 1860s, who used electroshock in patients in asylums to try and capture in sort of photographic plates what he saw as the movements of the soul using the human face as a map. Duchenne listed 53 emotions that he thought could be classified in terms of muscular actions. Now, Ekman also used photography. He used slow motion photography to capture what he called micro expressions, these sort of tiny movements in the face that could betray a person's true emotional state, according to him. He created this facial action coding scheme, or FACS, where you could actually annotate very closely these movements in people's faces. But it was extremely time-consuming. So when he was giving a talk in the late 1980s, there was actually an AI researcher present who said this would be a perfect problem for computers to address. So he started out a competition using the computerized version of FACS. And out of those competitions, teams were led by people like Jeffrey Cohn from the University of Pittsburgh and the computer vision researcher Takeo Kanade of Carnegie Mellon, who created this, the well-known Cohn-Kanade emotion expression dataset. Now, in this sense, Ekman's FACS system was an early inspiration for two things that were essential for later machine learning applications. A stable and finite set of labels that humans could use to categorize photographs of faces, and then secondly, a system for producing measurements. But in studying the long history of automating emotional detection, I found that there has been a deep vein of dispute since the very beginning. In fact, Margaret Mead, the anthropologist, debated Ekman at the very beginning of his research. She fundamentally didn't believe this idea that emotions are really universal. So you can sort of trace this all the way through to the current work by Lisa Feldman Barrett, which is frankly damning about technologists trying to assert that they can detect inner states from facial expression. And I'll read a quote from her here. "It is not possible to confidently infer happiness from a smile, anger from a scowl, or sadness from a frown, as much as current technology tries to do so when applying what I mistakenly believe to be the scientific facts." So why is it that despite this considerable evidence against inferring emotions from the face, that many AI companies are still selling these tools? Well, I think in many ways it's because, to some degree, if you're trying to do a very complex problem at scale, so say, for example, just assessing resumes, it's tempting to accept a system that says it can do it much easier and cheaper for you. This is part of the enchanted determinism that Alex and I have written about. Second, I think it's because theories like Ekman's fit what the tools can do, and they scale. They could be automated at scale by having a simple set of just 6 emotions. So these more complex issues of context, cultural conditioning, relationality can't be automated, and so they dropped out of the picture. And again, I think we should be very skeptical of any of these approaches that attempt to try and detect people's character from external issues like the shape of their head or their face. Of course, this image comes from Samuel Morton's cranial collection in the Penn Museum, and Samuel Morton was one of the people who tried to infer the intelligence of races from the size of their skulls. And of course, this was shown to be completely problematic. And while this race science was debunked, as Cornel West has argued, its dominant metaphors, logics, and classifications persisted for many, many decades afterwards. So I think Morton's work foreshadows the epistemological problems with measurement and classification that are being repeated in some machine learning applications. And of course, we've seen phrenological approaches in papers that claim to predict criminality based on your face or your sexuality based on images on dating sites. Now, all of these sorts of studies have been criticized for skewed data and methodological flaws. But I think the issue here is actually much more fundamental, which is that I think machine learning as a field makes a fundamental conceptual error when it seeks to predict people's emotions, sexuality, or criminality based on their face. It is a confusion of fluid and relational categories with fixed objects, as if we were measuring a chair or an apple. Race and criminality are simply not biologically determined. They are cultural, and the classifications we use have changed dramatically over the centuries. So it's also part, I think, of a long history of powerful institutions wanting to render bodies legible. From the polygraph in the 20th century to emotional detection in the 21st century, we've seen that this desire for a type of direct power is driving the sorts of tools that are being produced. And even when these technologies are debunked, for example, polygraphs cannot be admissible as evidence in court, these types of technologies nonetheless leave lasting and harmful legacies. So to sum up, today I've talked about how this sort of phenomenon of bias in AI is, I think, merely the tip of the iceberg. What we need to contend with are these deeper ethical, epistemological, and political questions. And these are all questions of power. Ultimately, AI is not an objective, universal, or neutral computational tool. Our technical systems are always shaped by humans, institutions, and economic imperatives that determine what they do and how they do it. When we apply them to humans, such as emotional criminality detection, they can import these sort of militarized logics and reproduce existing structural inequalities. But we rarely see the full scope of these tools until long after they're woven into our social institutions. Which is why I think it's significant that we're now seeing considerable scientific pushback against tools that infer personal characteristics from the face and body. People like Joy Buolamwini, Toby Walsh, Simone Brown, and myself have all been writing about these issues for several years. And in fact, Nature, in just the last year alone, has published multiple articles critiquing these approaches. And they even ran a survey of 500 researchers in which they found that 2/3 of respondents strongly agreed that using facial recognition to predict personal characteristics like gender, ethnicity, or sexual identity should not be done without informed consent. So I think the research community is seeing a real problem here. And personally, I would want to add inferring emotion from the face to this list. So what should happen next? Well, as the renowned physicist Ursula Franklin once said, the viability of technology, like democracy, depends in the end on the practice of justice and on the enforcement of limits to power. So right now, I think the field is at a turning point, and it's a critical moment for us to remember the lessons of power and classification of the last century and to recenter the practices of justice. I think when we see that our tools are both scientifically and ethically problematic, we need to act, and so do regulators. Otherwise, I think we will continue to see tools that will only serve entrenched interests and further intensify existing asymmetries of power. And I think that is an issue that concerns us all. Thanks so much.
Thank you so much for a thrilling talk. When I first heard you speak several years ago, you really shaped my thinking on this entire area, and I think you've done it again. I have to say, that I was fortunate to receive a preprint of your book. Thank you, and I enjoyed reading it. And we can certainly turn to some of the things that you didn't have time to talk about as well. But I actually wanted to so I remember when I first heard your talk at NeurIPS about bias, I had a hard time wrapping my head around the fact that an algorithm could incorporate bias from its designers and from society and then amplify. And so I think I finally figured that out. But here's the one that I'm thinking about today, which is the fallacy of face, mm-hmm. and why it exists. I think you really got me thinking right there, because here are these technologies that allow us to take shortcuts. Mm-hmm. But I think you kind of said it, which is that humans like to take shortcuts, right? If the algorithms didn't exist, we would probably we do take shortcuts. I think I was in a meeting just last week where there was a discussion about affects. No AI involved. And so I guess my question to you on this one is, I think, it makes a lot of sense to sort of hit the brakes on the deployment of some of these technologies, as you were pointing out. But it strikes me that the problem doesn't go away, right? Like if we just banned all AI to analyze affect and emotion, wouldn't we do it? I mean, we've been doing this for probably long before we've been around, and probably still going to happen long after we're gone, I think. So what's your thought on that? I mean, maybe we're the problem here.
Well, this is obviously a very sort of core question. And certainly when it comes to humans, we're often, reading or inferring people's emotional states as we're in conversations, as we're talking with people, and we're often doing that in shifting contexts. We're doing it, depending on who we're speaking to, where we are, what country we're in. These very contextual, cultural, and relational exchanges are extremely nuanced, and humans do them all the time. It's actually something that, we're trained to do from a very early age. But so many of those factors, those ideas around relationality, culture, context, etc., are not part of how we currently do affect detection in machine learning. We've created a highly simplified, and as we've seen, and certainly in the research is certainly playing out, highly problematically simplified understanding of emotion and its relationship to external physical characteristics. So it's not just that, we have a desire to make shortcuts and we'll always do them. It's that in some ways we've created highly narrow proxies for understandings of complex social relational systems that are always in flux. But our systems are not always in flux. They have a fixed set of attributes that are then being mapped onto complex situations and appearances and objects, and getting us only a very simple and in many cases incorrect answer. So I think what you're saying is partly true, but we've got a bigger problem here, which is that we're using the wrong proxies. We're using sometimes the wrong theories, and those theories are shaping our tools and then changing what we look for. So there's a very complex feedback loop here that is happening. Yeah. And I think ultimately, this is why we need to go really down to these sort of foundational theories and ways of seeing that we're using in machine learning, and ask what those assumptions really are.
That's really profound. It actually brings me to another question that I had written down, which is that you talk often in this talk and elsewhere about the effect of AI as amplifying bias, and I think one of the things that you just pointed out, I think the word that I think you might have used was fixed, right? A system stays fixed, and we move. We move on, we evolve, and I think you raise that in your book too when you talk about ImageNet's structural hierarchy and sort of being mapped onto WordNet. And you mentioned in the talk as well about WordNet being pretty old. And I had a question about that, which is that you often talk about amplification, but also, are there other effects that the use of these algorithms are having on us as people? For example, if the system stays fixed, right, and language is evolving, behaviorally we're evolving, but then there are these systems that are like, deciding, making decisions based on, the training data from a year ago. I could see one problem being like that the models just are out of date, but I could see this other weird problem happening where we start adapting to some old version of the world. I mean, so are these risks as well?
Absolutely. I mean, this is something that that I write about in Atlas of AI, but also, many people have written about before me. I would point to people like Ian Hacking, whose work, is a major influence here. And he writes about the way in which sort of these classifications that, as you say, sort of come from sort of historical sources, actually create representations that we begin to believe of ourselves. He thinks about this as another type of feedback loop, in fact, where classifications actually start to change human perceptions of ourselves and of other people, which is why they're so powerful and why we have to be so extremely careful in that work. So you're absolutely right. And you can see so many examples of how classifications have sort of had those sort of profound impacts, not just on us, but on how we see other people. And one of the examples that I've used is really looking at say, for example, the way homosexuality was described, in things like the DSM, the Diagnostic Manual, as a sexual disease or as an aberrant behavior. And it took sort of years and years and years, decades of activism to really sort of change those classifications. Those classifications had profound and horrifying impacts on so many people. And so again, it just reminds us that these classifications are powerful. They shape relationships to the social, and we should be treating them with extreme care.
Great, thanks. So I see a lot of questions coming in. I want to turn it to Rob in just a second, but I can't resist a couple of them. So every time I hear you talk, I think, boy, maybe we should just stop using we should stop using a lot of these technologies. But I had sort of two thoughts there that I'll just kind of lump into one question. One is that a lot of the critique, I think, that focuses on supervised learning and labels and classification. And I'm sort of wondering, in one case, what about unsupervised learning? On the one hand, no labels, no problem, right? But on the other hand, unsupervised learning is designed to recognize patterns and structures in data. And I'm wondering, sort of what your thoughts are on unsupervised learning. And then I think as sort of a quick follow-on to that, are there areas, let's say areas of machine learning that, don't involve people, which might arguably be none. But, I'm thinking, for example, network security or something like that. Still involves people, but are there some areas of machine learning that are maybe, safer or less fraught than others? Classified learning on people seems to be a real third rail, but what about unsupervised learning? Or what about sort of applications of ML in other contexts like systems?
Mm-hmm. Well, I think what's interesting is that there's an enormous amount of nuance here. And I want to sort of really underscore the degree to which the fact that you're saying that there's third rail in terms of thinking about supervised machine learning on humans, that really wasn't the case as recently as, 4 or 5 years ago. It really has taken the work of many, many researchers to really draw to attention these sorts of issues. But I would suggest to you that there are these kinds of epistemic questions, these questions of how we make knowledge that are actually true of every single one of these fields. And certainly there's work that points to these issues in unsupervised learning as well, because of the data that you're choosing. That data has patterns, and those patterns have, in many cases, forms of structural bias and again, problematic forms of representation throughout them. To see that, all you need to do is to really stop and look really closely at what that data is. And that's not something that we have trained people to do in computer science. What tends to happen is that training sets are just seen as infrastructure. Grab them, apply them, move on. That is one of the big issues here. I just don't think we can be doing that. We need to treat that as a sort of fissile material. It's extremely sensitive, and we need to have a much greater sense of what it does, how it works, what's in it, and what's not in it. And I think that applies across the board. Is there a space where, like network security that somehow doesn't involve these questions? Tragically, no. Even in network security, I'd say even particularly network security, we have to think about how humans work and what the assumptions are around what is protected and what isn't protected, how attacks happen, what we decide as being threat vectors and not. And I think in some ways you could even see some of the issues around network security not being applied to things like hate speech or various forms of harassment online, where you saw a real break that should have been seen as sort of network security and safety issues. And again, these are about what are your core assumptions and how do those core assumptions affect people, particularly marginalized community, by which, often it's women, it's people of color, it's sort of BIPOC communities. This happens over and over again for the reasons that we discussed earlier. So frankly, I have to say that when we start looking at questions of epistemology, it's turtles all the way down.
Good. There's plenty more to talk about, and definitely you've once again tuned my antenna to some really important issues. So thanks for that. And I think I'll put in a plug for some of the things you didn't have a chance to talk about. Maybe there's some questions that did come up, but I think the other thing that I think is lovely about your book is we've talked about how machine learning affects people, but I think the other part of your book I really liked was how machine learning, or artificial intelligence, I should say, uses people and on the back side. So I think, in terms of production of data sets, in terms of the Wizard of Oz behind the curtain and so forth. And so another plug for your book, I think, is very eye-opening. So we'll have to have you back for another talk on that. But I guess I should turn it over to Rob so we have time for some questions from the group.
Yeah, as Nick mentioned, we have a ton of great questions here in the chat. Still time to drop your questions in the chat if you would like to, either on YouTube or Zoom. I'll start with one from Nicole Marwell. She says, one of the issues that propels the kind of epistemologically faulty computational approaches that you critique here is the availability of resources, government or corporate, for that kind of work. In contrast, comparatively few resources are available for the kind of work that would push forward the development of the tools of justice you suggest. Can you comment?
Well, that's a really interesting question. I mean, if we look to funding imperatives, certainly the history of the last sort of 60 years of development of AI and ML has been a story of almost entire sort of commitment of resources to technical innovation rather than asking sort of social or epistemological questions around their construction. That, I would say, has changed a little in the last sort of, 5 or 6 years, where we're starting to see a real outcropping of research centers that are focused on these, social, political, and also ecological questions around large-scale technical systems. We have a lot further to go. So I would agree with you that in order to really support the kinds of deep and frankly time-consuming work of doing this sort of more critical research, it certainly needs to be sort of more widely funded. But that's something that I know many of us are working hard to try and produce. But I just couldn't agree more that the history has really prioritized the technical over the social, and I think we're now living the effects of that, and it's really quite troubling. So it's something that we need to realign certainly over the next few years.
Thank you. Another question from Matthew Turk, who asks, first a comment. He says, most researchers in facial expression analysis understand well that there's a big difference and a complex relationship between expression, the visible variables, and emotion, the hidden variables. In some sense, the problem is with the smaller number of bad actors, bad reporting, bad PR by companies making the irresponsible claims. Do you think it's possible to continue pursuing reasonable and valuable research and applications in medicine, computer graphics, et cetera, from the dangerous improper uses?
I really like this question, and I like that you're raising this sort of distinction between sort of bad actors using these tools in ways that are irresponsible and sort of more so-called responsible uses. Even here, I think we have to be really careful and nuanced in our thinking, because certainly, we're talking about large companies, like HireVue, which was using sort of affect detection and emotion recognition in its sort of HR and job interview tools, which has now deprecated those tools and is no longer using them. It's saying this is a problem, we won't use this anymore. And that came about because of so many researchers raising these questions and journalists reporting on these questions. So sometimes, you actually need reporting and research to call out real problems in order to have change. Now, it strikes me that we did have a point in time over the last few years where affect detection was being sprinkled into so many technical systems without real sort of concern or without any pushback whatsoever. So I think it's actually really important to raise up that work and say it is good that people are testing these systems, that they're actually auditing and looking at how they can fail us. Now, in terms of where they are succeeding, that again is going to get to, can you actually look at these in a more nuanced relationship? Now, Lisa Feldman Barrett, her work has really been profoundly impactful in saying that any kind of direct relationship between facial movements, sort of facial muscle movements, and internal states is not absolutely mapped one-to-one. You cannot say that this facial expression refers to this internal state in a consistent way. So that means that I think in all of these applications, much more care, much more caution needs to be brought to where they're applied, how they're applied, and then how, as you say, they are articulated to the public and how they are sold. Every one of those steps, I think, now really raises a lot more red flags. And I think we need to be thinking a lot harder about how they work. Great question, though. Thanks.
One question that summarizes a couple of different questions I've seen here in the chat comes from Sean Chan, who says, thanks for the wonderful talk. What are your suggestions on addressing these biases from computer scientists' standpoints? It seems unrealistic to wait for policies to stop these problematic practices.
A lot we can do. And frankly, one of the things that I've really loved about this series that Nick has hosted has really been the many different responses that people have had in terms of how we mitigate these problems. But I think one thing that you'll see as a consistent theme is that it can't just be done in computer science. It actually has to be done in an interdisciplinary way. We really have to be including people who have deep expertise in other fields, from anthropology to sociology to healthcare to education. That's where we're actually going to have, I think, much deeper analysis and more nuanced understandings of what should be built, but perhaps also of what shouldn't be built, of where the systems are actually simply not going to serve us, or where the risks and the harms are too high. So I think that's one of the things that is going to be really important in the next few years, is I think in some ways stopping the so-called inevitability of tech, the idea that because we can do something, we should do it, and there must be a way to sort of make this tool and make it profitable. I think we have to ask harder questions, like, is this actually the right tool? Should we make it at all? Or does it actually present too many negative externalities? So certainly, I think in future, we should be seeing AI as a field, as an interdiscipline, as a space where we have people coming together from very different perspectives and actually, using a very high level of care and a precautionary principle in terms of the systems that we make and deploy.
Thank you. A question from Jordan Jackson. What education, mindsets, and groundings have helped you develop your critical thinking about technology?
Wow. A lot of them. That's a great question. So I started out studying political philosophy and law, and I taught myself coding very early on, because it was very clear to me that this was like a sort of fascinating space, and computers really fascinated me from an early age. But in terms of my sort of traditional academic training, came from more the humanities and the social sciences. And then it wasn't really until I started really looking at sort of machine learning and how profound a set of techniques it could be, where I started to see that we need to bring these disciplines together. So for me, I'm a big believer in essentially kind of learning across many different kind of disciplinary domains. But also I've been influenced by lots of different people. And so it's not just academic disciplines, but humans who have had huge influences on me, people like Lucy Suchman, Peter Gauss, and Simone Brown, really learning from others and allowing that to sort of light the way in terms of how I understand these issues.
Thank you. We have time for, I think, just one final question, and then I'll send it back over to Nick. Yali Amit asks, do you think the type of research you are proposing has a chance of really developing and having an impact inside the big companies such as Google, Facebook, Microsoft, or Amazon?
Well, frankly, I think we are having a pretty significant crisis as a field in terms of how this work is done in the corporate sector. Just in the last month, we've seen, ethics boards get shut down. We've seen sort of leading AI and ethics researchers be fired. We have seen large platform companies really conduct, I would say, extraordinarily harsh forms of negotiations around regulation. For example, I'm thinking here of Facebook completely shutting down its newsfeed to all of Australia, where I am currently, because it didn't like the way that a particular media bargaining code was shaping up. So we are at a moment where we have to ask very seriously, what are the ways in which this space is going to be governed and regulated? And that is why, I sort of think that Ursula Franklin insight is so profound that the viability of the field of machine learning is going to depend on the practices of justice and the enforcement of limits to power. And what we're seeing is that that's going to be quite a complex fight. It's going to be extremely important, however, that we do it. So I would say to you that, you've raised probably one of the most important questions that can be asked right now. And it's something that as a field, we have to contend with, because certainly the things that we've seen in the last month have been sort of profoundly disturbing, and we're going to need some real change.
Thank you so much. And thank you to everybody who asked questions. They were really great. Sorry, we don't have time to get to all of them this evening, but we'll turn it back to Nick just to say a few words of goodbye here.
Thanks, Kate. Really appreciated your talk, your comments, your response to all the great questions. I just had one final question for you as a fellow member of the Academy, a fellow professor. Which is, how do we think about teaching, the type of thing that you mentioned? Now, your talks, as fantastic as they are self-contained. And so I think my question earlier, right? No part of our field is immune from these types of questions, right? We can no longer teach, network security and applications of machine learning without thinking about the types of considerations that you raised. And on the other hand, aside from what we learned from you in talks like this, we're not experts. And so how do we teach it? It seems to me that we can't just teach. We can't just put it on as a side course, right? It needs to be integrated. But given that not all of us are experts, how do we do it?
Well, Nick, I mean, this is a topic for a whole other hour-long discussion in and of itself. So I don't want to try and answer it as briefly or in any way in a glib way, because what you're asking is a core question of pedagogy, and how do we do this right? Because that is how we're going to influence the next generation of people who are making the systems that influence everyday life. So it's profound, but I would return to some of the themes that the questions have touched on already, which is these questions around interdisciplinarity and the siloization of fields. I mean, that's where we've had real problems, is the way in which computer science really sort of came from mathematics and sort of saw itself as a field that was entirely separate from the social sciences and the humanities and fields that were oriented around studying and understanding people. We don't have that type of separation anymore. These are not theoretical disciplines. These are disciplines that are affecting the lives of billions of people. And that means, in terms of how we teach them, we need to really sort of have a revolution around including the idea of the social and how we understand people from the very beginning. That's a really big shift, but it's one that I think is going to be important if we're going to do this right.
Thanks. Those are inspiring words. Hopefully we can all go forward and teach the next generation. Thank you so much. Thanks for your time. Have a wonderful rest of Tuesday, I guess it is. You're ahead of us as usual.
In the future.
That's right. And thank you so much. And I'll just use this opportunity to just quickly wrap up. Professor Crawford is the last in our series. I'm sad to see it end. I've learned a lot. Thank you for joining us, Kate. We really appreciated it.
Thank you all for being here, and thank you, Nick, for curating this fantastic series.
Great. And everybody, I should say, everyone should read Professor Crawford's book. It's if you like today's talk, it's more of the same. Very enlightening. Thanks. Great. Oh, right. And lest I forget, the penultimate question was about industry. And so we'll be talking about some of the how AI industry is thinking about AI in related series. We're having Martin Casado, who's a general partner at Andreessen Horowitz. He's done some really interesting writings on how AI is shaping the software industry. And next month we'll be talking with Martin a little bit about that. And now we know from today's talk that even those topics are not immune from what we heard about today. So I'm going to be spending the next few weeks thinking about new questions to ask Martin. Stay tuned. You can follow us here on YouTube, on Twitter, LinkedIn, GitHub. We also have open source projects that we're working on, and you can go to any of these places to learn more about the Center for Data and Computing. And once again, thank you today to Professor Crawford for such an inspiring, great talk. And we'll see all of you soon. Thanks.